So multiplying and dividing our rational expressions is not that different than our simplifying. It's just got that one extra piece to it of you are either multiplying or dividing something. So if you have two fractions that you are multiplying, let's say, for example, I have the fraction of a over b, where a and b just represent a monomial of some kind, whether it's just numbers, or it's one that has numbers and letters. Same thing for c and d. When we're multiplying, what we do is you just multiply the tops together, and you multiply your denominators together. So you hit have AC over BB. Now, a lot of times, once you have the variables thrown in there, when you multiply, you can get some pretty big numbers. So what we try to do is we try to simplify that down as much as we possibly can before we actually go through and do our multiplication. So the way we do that is we first factor the numerators and the denominators. So you factor them out, see if they have any common terms, and then we're going to cancel out the common factors, which is our step 2. So remember, when you cancel, it's 1 from the top with 1 from the bottom. Can't take 2 from the top with 1 from the bottom. It's 1 for 1. And when it comes to multiplying fractions, you'll have the two fractions there, and it doesn't matter which numerator or which denominator it comes from. You could have it from the numerator of the second fraction and the denominator of the first one. They'll still cancel each other out. It's just 1 from the top with 1 from the bottom. So then we multiply our numerators and multiply your denominators. And then occasionally you will have to reduce again. Not all that often because we've already done the reducing, but sometimes it does happen, so you would try to reduce if you could. So let's take a look at our example. So we're going to multiply each expression, state any restrictions on the variables. And remember, where do the restrictions come from? Restrictions are on the originals. So let's actually figure this out first. If I look at my first fraction there, the x minus 3 in the denominator, what would be my restriction on that one? You would add your 3, so we would get a restriction of 3. So x can't be a positive 3 because it would make a 0 in that first fraction. How about for the second one? Negative 2. So there's our two restrictions. We can't have a 3 or a negative 2. Again, that plays a bigger role when we actually go to start solving, but we practice how to find them now so that when we go to solve, it's very fluent for us. So as I said, step 1, we're going to try to factor. So let's look at our numerator of our first fraction there. X squared minus x minus 6. Can we factor that? Yes, we can. Oh, good job, guys. We got a trinomial there. Will our signs be the same or different when we factor? Different. That minus at the end means they're different. So I'm going to have an x plus, and I'm going to have an x minus. So we got to think of what multiplies to give us 6, but will add to give us a negative 1. So let's focus on the 6 first. What multiplies to give us 6? 3 times 2. Which one's going to be my negative? The 3. So I got my x minus 3 and my x plus 2. Can I factor the denominator here? No. So I just rewrite it. Can't factor that. How about the numerator of the second one? Nope, can't factor it. Just a 2. Do we factor that denominator? Nope. So I'm just going to rewrite that one. So this one we only had one thing we needed to factor. So now our second step is we cancel out any of our like terms. So x minus 3 is going to cancel with x minus 3. 1 from the top with 1 from the bottom. What's the other stuff we can cancel? The x plus 2's. 1 from the top with 1 from the bottom. So what are we left with? 2. So our answer is 2. And we've already got our restriction there of x can't be 3 and it can't be a negative 2. All right, let's look at our second example. Let's do our restrictions first. Let's figure out what x cannot be equal to. So if we look at the denominator of this first one, because that's an x squared, that kind of tells me there's going to be two numbers from that one that x cannot equal. How would that factor? 3 and 1, right? Because 3 times 1 gives us 3. Gives us a 2 in the middle. So I'm going to keep it down there in the denominator still, because we're going to need it eventually when we're trying to simplify. But the 3 and the 1. So when I set this equal to 0, what would I get? What value? Negative 3, so there's our first one. What would the x minus 1 give us? Positive 1. Now for the second fraction, our denominator there is a 4x. I can't factor that any further. But is there a value that would make that a 0? If I plug something in for x, would I get a 0 here? Yes. You don't have to write this, but if we put a 0, divide by 4, what's 0 divided by 4? 0. So there's our last one. So x can't be those 3 numbers. All right. So to finish our multiplication, we got a little bit more factoring to do. How do we factor the numerator of that first one? GCF. What is our GCF? 4x. And then I would have an x minus 1. How about the numerator of that second one? It's kind of similar to our first problem. The only difference is that middle term is different. So it tells me it would be plus 3 minus 2. Same numbers, multiply to give you 6, just one's plus, the other one's plus and the other one's minus. So now what can we cancel? X minus 1 with x minus 1. The 4x with the 4x. And then the x plus 3 with the x plus 3. So then we're left with x minus 2. So it simplifies into x minus 2 with our restrictions of it can't be negative 3, 1, or 0. All right, let's look at our third one here. So let's try to do our restrictions first. So in order to do that, we got a little bit of factoring to do. So I'm going to try to do that all at the same time so I don't have to write the same thing like 6 times. So looking at our denominator here of the first one, x squared minus 1, can we factor that? Yeah, that's our dots factoring. We got 2 perfect squares there. So how does that factor? X plus 1, x minus 1. And again, the order doesn't matter. Whichever way, as long as they're both there. So if we set these equal to zeros, what values do we get? 1 and negative 1. So there's our first restrictions. X can't be 1 and x can't be negative 1. How about the second denominator, the x squared plus 2x? Do we have a GCF? So then we're left with x plus 2. So for this one, we could set this GCF of x equal to 0. So we would have a 0 as another restriction. What would the other one be? Negative 2. So that one's got 4 restrictions that time. So let's finish factoring out our numerators. X squared plus 4, that's another dots. So that would be x minus 2 times x plus 2. Can we factor x plus 1? No. That stays as x plus 1. So now what can we cancel? The x plus 2s and the x plus 1s. Anything else? Nope, the rest of them aren't identical. So in the numerator, we have that x minus 2 still left. In the denominator, we have two things left. We have this x minus 1, and we have that x that are both still there. So that, we're going to multiply them together. So it would be x times x minus 1. And you can leave it just like that. You don't have to actually distribute through with your x. You can leave them as that factored form right there. So there's our final answer for that one. X minus 2 over x times x minus 1 with our 4 restrictions of 1, negative 1, 0, and negative 2. All right, one more example and then we'll take our break. Bless you. So that first one, y plus 1, it's not a fraction. Or is it really a fraction? It is. What is it over? 1. Remember, we get lazy as mathematicians. We don't like to write the 1s if we don't have to. But it's there. So that's still y plus 1 over 1. So there's really no way to factor that one. That one's going to stay as y plus 1 over 1. Can we factor the second denominator there? Yeah, that's going to factor. We got a dots factor there. This would be 1 minus y times 1 plus y. And remember, don't switch the order. You've got to leave it like that. So for our restrictions, there's none from the first fraction, because that's just over a 1. There's no variable there, so there's not going to be a restriction on that one. What would our two restrictions be on the second one? 1 and negative 1. That's the two values it can't be. Can't be 1, can't be negative 1. So now what can we cancel? Y plus 1, y plus 1. Remember, commutative property, those are the same thing. We can switch that order. So y plus 1 and then 1 plus y cancels. So we're left with y in the numerator. And then it's 1 times 1 minus y for our denominator. There's our final answer to that one. Question? Yeah, commutative property allows us to change that order for addition. So dividing our rational expressions, so dividing our fractions, there's just one extra step. Dividing your fractions is very similar to your multiplication. We've just got that one extra step. When you're dividing fractions, you have to do keep, change, flip. You guys remember hearing keep, change, flip? KCF always makes me think of KFC. I don't know why, but it just always does. KCF. Yep, it does. So that first fraction you keep exactly the way it is. You keep the numerator, keep the denominator, nothing happens to it. You change it then to a multiplication, and while you do that, you flip the second fraction. So keep, change, flip. And then it's just like a multiplication problem. Multiply your tops, multiply your bottoms. But like we were doing before, to try to keep that from becoming a really huge thing, we factor first and try to cancel out any like terms to try to keep it smaller. So steps would be to first turn the problem into a multiplication problem by doing your keep, change, flip. We do that by flipping the second fraction. So if you see me start writing KCF, that stands for your keep, change, flip. And then writing it that way is what always makes me think of the KFC. So we're going to do some examples. So we're going to divide each expression, state any restrictions on the variables. Your restrictions come after it becomes multiplication. So after you've changed the division into the multiplication problem, that's when you figure out what your restrictions are going to be. So I'm going to try to do a couple of steps in one, just so we don't have to keep writing the same thing over and over again. If it's too much, please just tell me and I'll stop doing it. So 5x plus 15, can we factor that one? Yes, what's our GCF there? 5. Then we have an x plus 3. How about that denominator, x squared minus 9? Yes, how does that one factor? X plus 3, x minus 3. So as you can see, I've already changed it to multiplication. So I've done my keep, changed it to a multiplication problem. So now we're going to do our flip. So we're going to factor the denominator of the second fraction first. So 4x plus 12, or minus 12, does that have a GCF? 4. And then we get x minus 3. So I put that in my numerator now because we're flipping it. How about the top? 10x. And then we would have x plus 1. So now that I've turned it into the multiplication, now I can figure out my restrictions. So in the first fraction, we're going to get two numbers that it can't be. What would those two numbers be? 3 and negative 3. Negative 1, and there's one more, 0. If you ever got just the x there, even if there's a number in front of it, if it's just x, there's no plus or minus with it, that one's always going to be a 0. So now let's do our canceling. X plus 3s, x minus 3s. Can we reduce anything else? The 5 and the 10. Yeah, we can reduce that. How many times does 5 go into 10? Twice. So this is really a 2x now instead of a 10x. And the 5 is gone because we've reduced it with the 10. So we would have 4 over 2x times x plus 1. So 4 is the only thing left up top. Those two things were left in the bottom. But looking at that, can I reduce that 2 and the 4? Yeah, so this is when you have to sometimes maybe reduce it again. 2 goes into 4 twice. The 2 from the denominator is now gone. So 2 over x times x plus 1. Along with our 4 restrictions makes up our final answer there. So again, really same thing as what we were doing on the front. You just got that one extra step of keep and change flip. So let's try it again. So again, I already set up my multiplication because I know I'm going to have to flip it. Numerator of our first fraction. What's our GCF there? And then we got x plus 2 in our parentheses. Can't factor that denominator. So that's going to stay as our x minus 1. 2 and 3. But where does this one go when we factor it? Yeah, it's going to go in the bottom. Remember, we got to flip that. So which one's going to be my negative for this? The 3. So we have x minus 3, and the x plus 2 is now in our denominator, so we got to flip it. And then how does the other part factor? Yeah. Plus 3 and minus 1. So before we start doing all of our canceling, let's figure out our restrictions. There's going to be 3 of them this time. So from the first fraction, what number would make that a 0? 1. So if I put 1 in for x, 1 minus 1 gives me 0. So 1 is our first restriction. 3 and then negative 2. There you go. 1, 3, and negative 2. All right, so let's start our canceling. Yep, those x plus 2's are gone. X minus 1's are gone. Can I cancel my 3's? Nope, because one's plus, one's minus. Not exactly identical. So up top, we still have this x, and we have that x plus 3, so we'll put x times x plus 3. In the denominator, we just have that x minus 3, so that's just going to stay as x minus 3. And there's our final answer for that one. All right, number 7. Again, that second one, it's not written as a fraction currently, but it is. It's over a 1, so we always got to remember that over 1 there. I'm going to set up my 2 fractions. The second one, I don't have to do any factoring for that one. I just got to flip it. I always like when those ones happen. Those ones are easy, no factoring, so let's just flip it. The first fraction, I can't factor that denominator, so that's just going to stay as 4x. Keep, change, flip. Keep, change. You always flip that second one when it's division. Oh, because I didn't realize I did that. Thank you. It was an accident. Sorry, I didn't realize I flipped that. All right, so that top part up there multiplies to 2, adds to give us 3. What do we have? Negative 2 and negative 1. So let's do our restrictions first. There's going to be 2 of them. From the first fraction, what makes that bottom a 0? 0. From the second fraction, 1. 0 and 1 are our 2 restrictions. So can we cancel anything? The x minus 1 with the 1 minus x, but because they're opposites and they're subtraction, what does it turn into? Negative 1. Now you could put the negative 1 in the bottom, but I just have the habit of putting it in the top. It's not wrong if you put it in the bottom, but I find it's easier if you just have a pattern, you keep putting it in the same place. Your life will be easier. So there's nothing else we can cancel. So we have a negative 1 times the 2x, or the x minus 2 times the 1. So I can just leave the negative 1 out in front there. And it would be over a 4x. So I just want to show you something. This answer, perfectly acceptable. Sometimes, though, you may see it written with the negative sign from that negative 1 all the way out in the front like that. That's the same answer, just written in a different way. And then the other thing is sometimes they'll actually distribute the negative and write it like that. So the times where you would see those ones are kind of if it's a multiple choice question. So just keep in mind, those are all the same thing. All right, last one. We got 3 fractions there. They're eventually going to be all multiplications, so I'm going to set up my 3 fractions with multiplications in the middle. So let's start our factoring. First one, numerator, do we have a GCF? X. So x times x minus 3. Bottom is a trinomial. Multiplies to 10, adds to 7. 5 and 2. So that second fraction already had a multiplication sign in front of it, so we're not going to flip that one. That's going to stay the way it is. Is there a GCF in the top? 6. And then we got an x plus 5. Denominator doesn't have a GCF because it's just a single term of 8x, so that's going to stay as 8x. Now that last one had the division sign in front of it, so that's the one we're going to flip. So looking at the numerator, that is a trinomial. That's going to become in the denominator now. What multiplies to 15 but give us a 2 in the middle? 5 and 3. So we have plus 5 minus 3. And then the x squared minus 4. X plus 2, x minus 2. All right, let's do our restrictions. We'll go through each fraction one at a time. So the first one, what are the two numbers we get from the bottom? -5, -2. Second one would be 0. -5, positive 3. I already have -5 there, so I don't have to write it again. So I'll just write the 3. All right, let's start canceling. It's always my favorite part. I love canceling these things out. Yep, so remember, x plus 5 can only cancel out one of the x plus 5s in the bottom. 1 for 1. X plus 2, x plus 2, x minus 3 with x minus 3. Now this x will cancel with just the x from down there. The 8's still there, but the x's will cancel with each other. Now we can also reduce those numbers, 2 and 8. What can we divide those both by? I'm sorry, 6 and 8. I already said it. That'd become 3. That one would become a 4. So up top we would have 3 times x minus 2, because that's all that's left, over 4 times x plus 5. So from all that we started with, that's what we end up with.